Alright, let's look at the homework 7.4, problem number 10. Alright, so we want to find the area of the region under the graph of the following function from 1 to 2. Alright, so all we really have to do is integrate it from 1 to 2. Alright, so area is going to be integral from 1 to 2, 13 over x cubed plus 5x with respect to x. Right? So let's use the partial fractions here. Right? So we have 13. Right? I'm going to factor x out because x is in common. So we have x. Then we have x squared plus 5. Right, so this is equal to. Right, so we have linear factor x. So you have constant on top, a. And we have quadratic factor. So we're going to have bx plus c, right, over x squared plus 5. Alright, then we're going to put them back together. So the common denominator is the original denominator, x squared plus 5 times x. Alright, so a we need to multiply by x squared plus 5. And for bx plus c, we need to multiply by x. Alright, so let's compare the numerators here and the numerator on the right hand side. Alright, so let's multiply out. So we have, if you multiply, distribute a to x squared and 5, we get a x squared plus 5a. Right? Then we distribute x to bx and c. We get plus bx squared and plus cx. Alright, so this is going to be equal to 13. Alright, so let's compare coefficients. Alright, let's look at the coefficients of x squared here. Alright, so we have ax squared here and the bx squared. So coefficients are a and b. Right, but there's no x squared term on the right hand side, so this has to be equal to 0. Alright, so let's look at the linear term. Alright, so we have, let's see, there's only one. Alright, so you have c is equal to, there's no linear term on the right, so it has to be 0. Alright, and let's look at the constant term. And there's actually only one constant term here, so it's 5a. So it's a 5a is equal to 13, because the constant term on the right is 13. Alright, so we already know what c is. C is 0. And from here, we can just divide through by 5. A is going to be 13 over 5. Right, so then we have, since a is 13 over 5, plus b is going to be 0, so we can just simply subtract 13 over 5. So b is going to be negative 13 over 5. Alright, so we have everything we need. So we have value of a, value of b, and we know the value of c. Alright, so let's finish up the integral. Actually, I'm going to continue on here. Alright, so we have an integral from 1 to 2. Alright, so a is 13 over 5. Alright, so you have a, I'm going to put the 13 over 5 here, then over x. So it's going to be just multiplied by 1 over x. Alright, and then b is negative 13 over 5, so I'm going to put the negative 13 over 5 x over x squared plus 5, and the c is 0, so that goes away. Then we have to evaluate it with respect to x. Alright, so I'm just going to make one adjustment. So since denominator is x squared plus 5, we would like to have its derivative, which is 2x. So I'm going to put actually 2 here and 1/2 in front. Alright, so we have that. Then let's see. First thing I would do is I'm going to pull out 13 over 5. Right, so let's pull out 13 over 5. So there's a 13 over 5 here, and there's a 13 over 5 there. So I'm going to combine that and pull that guy out there. Right, so we have 13 over 5 there. Then you have an integral from 1 to 2. Alright, so we have 1 over x, right, which we know how to find the antiderivative, and a minus 1/2, and then you have times 2x over x squared plus 5. Alright, and with respect to x. Alright, and I'm gonna go down here, right? So we have a 13 over 5. Right, antiderivative of 1 over x is natural log of absolute value of x minus 1/2. Then antiderivative of 2x over x squared plus 5 is natural log of absolute value. Actually, we don't really need absolute value. X squared plus 5. And then you are going from 1 to 2. Right, so plug it in. Right, you have 13 over 5. Alright, so if you plug in 2, so you have a natural log of 2 minus 1/2. We have natural log of, let's see, 2 squared, 4 plus 5, so it's a natural log of 9. And a minus, right? Plug in 1, so you get natural log of 1. And a minus 1/2, natural log of 1, so 6. Right? Then we just have to simplify that. We're almost done. Let's see, I'm going to just change that to square bracket so I don't get confused. Alright, one thing is here, natural log of 1 is just 0, so this is 0. So I'm going to simply just scratch that out. Alright, and then I'm going to actually put 1/2 here and put it over here. So it's a 1/2 power here, right? So we can just I can just scratch that, put that. So this is going to be actually a natural log of 3, right? And then let's see, same thing with here. So we have a 1/2 here. We can put it over here, right? So it's 1/2 power. And if you want, I guess we can write it as natural log of square root of 6. Right? So what you get is going to be, right, so 1/3, sorry, not 1/3, 13 over 5. Alright, so I'm going to put all three natural log in 1. So you have a natural log, alright, 2, so 2 is going to be on top. Alright, 3, so it's a minus 3, so 3 is going to be on the bottom. Alright, and then you have negative minus, so square root of 6 is going to be actually on top. Alright. So we have, let's see, I'm going to just put it in the right place. Alright, so we have that. Oops. Alright, so this is the area of the indicated region. Alright, let's see if we did this correctly. So I'm going to type it in. Alright, so you have 13 over 5. And natural log of 2 square root of 6 and over, what was it, over 3. 3. Alright, so let's check the answer. Submit for testing. Alright, I came back and looks like we did this one correctly. Alright, that's it. I hope that this was clear.